welcome to the session on Shield Secrets by Vidushi. We'll probably wait for a minute, and after that we'll start. In the meantime, if you have any questions or any inclination towards any particular topic, you can let us know, and then we can take the discussion in that direction as well. And if you don't have any questions, we'll probably get started ASAP. As you already know, that for Shield Secrets, be it for Kubernetes, or let us say encryption for protecting your password, Shield Secrets is a typically easily encryption, or let us say public key cryptography, right? So I hope you already know the difference between public and private and what gets encrypted on the fly and on rest. We'll get into details of these, and we'll take it forward from there. And if you have any questions in between, please let us know. All right, then if I think we are on time, so over to you, Vidushi. Take it away.
Thank you, sir. As Rahul sir mentioned, feel free to reach out to me or feel free to ask questions anywhere in the middle. And please let me know if my screen is visible now. Can somebody give me a confirmation?
Yes, your screen is visible, Vidushi.
All right. So, hi everyone. Today I'm going to present a knowledge session on Shield Secrets. And before we jump into the session, here are some mandatory knowledge etiquettes that you need to follow. Punctuality, please respect the knowledge session timings. You are requested not to join the sessions after a 5 minutes threshold post the session start time. Feedback, please make sure to submit a constructive feedback for all the sessions as it is very helpful for the presenter. Silent mode, please keep your mobile devices in silent mode and feel free to move out of the session in case you need to attend an urgent call. Avoid disturbances. I'm sure we are working from home, so we would avoid the unwanted chit chat during the session. Okay, the topics that we would go through today are what are Shield Secrets, why to use Shield Secrets, and the components of Shield Secrets and how it works, followed by a short demo. So before we actually talk about the Shield Secrets, let's first have a look at some prerequisites that will help you understand this topic better. Kubernetes. I'm sure you must be aware of what is Kubernetes. Can somebody please give me a brief about what is Kubernetes? I see we have a lot of DevOps people in the group. Can somebody volunteer? Okay. Okay, if not, Kubernetes is just an open source system for automating the deployment of applications. It also helps in the scaling and management of containers. So in very simple or layman term, if you have an application that you want to host on a server and serve requests from the users, you can easily use Kubernetes for the management. It will take care of the deployment and it will also take care of your scale ups and scale down of the resources as and when required. Right, so Kubernetes works with multiple cloud platforms, as you know. It includes AWS, GCP, Azure, and on-prem servers. Right, so it has multiple resources that manages the applications within the infrastructure. One of the feature of Kubernetes is, of course, its secret and configuration management. Can somebody tell what a secret is? Can somebody tell if I'm audible or not?
You are audible, Vidushi, but people are not able to speak.
Vidushi, I think only presenters are unmuted.
Oh, yeah.
Yes, presenter can only speak and others can reply over chat if you are asking any questions, okay?
Okay, got that. So sorry. Okay, let me tell you what a secret is. It's just an object that will contain some sensitive information, such as your password, your token, or a key. Right? And Kubernetes secrets are stored unencrypted in the API servers underlying the data store. We are aware of HCD. That is where the secrets are stored. So the very important point to note is they are unencrypted. They're just encoded, right? So if a user has access to HCD, the user can also easily access the secret. So that is why it is advised to use an external secret store providers. We'll come to that sometime later when I present a knowledge on that. But for now, we're talking about sealed secrets. So there are several ways in which you can secure the secrets, and there are multiple options available in the Vault and Safe Providers section. So cloud providers as well as the Vault, they are very effective to handle the secret management in Kubernetes. Problems with secret in Kubernetes, there are many problems actually, but most importantly, the secrets, as I told, are not encrypted. They are just encoded via base64 format, right? So it's very easy to decode a secret. And the YAML for secret, it's not advisable to store that YAML in a GitHub repository just because it has that encoded value. And if you have, or if somebody has access to your GitHub repository, it is very easy to decode the value of a secret. So usually it is very possible that a developer might push that secret YAML to the GitHub repository and anybody can access that, right? And also the certain applications also expose the secrets in audit logs and monitoring systems. For example, if you use an API, that API is requesting your database, and that API requires the credentials to your database. In the logs of that API, you might also find the value of a secret, say a DB password, right? So this was the problems with secrets in Kubernetes. So there are many suggestions offered by the Kubernetes in the official documentation for Kubernetes, of course. So the first one is enable encryption at rest for secrets. By default, the secrets are not encrypted at rest. In HCD, they are just encoded, right? So it's very easily accessible. So it's advisable to enable the encryption at rest. Second, enable or configure the RBAC rules. We can definitely configure the role-based access control, and we can provide the minimum privilege to access those secrets. Third, restrict secrets access to specific containers. Let's suppose if you are working with a multi-container pod and only one of the container requires the access to secret. So we can only allow that particular container to access that secret. Fourth, consider using an external secret store provider. So we also have multiple options available to provide this access to sensitive data by means of vaults. Some of you might be working with vaults and would be very well aware of that. Up till now, if you have any questions, I will look at the chat window. Yeah, I know you cannot unmute, but you can type your questions here if you have any. Okay. Let's move further. We have a very interesting approach called GitOps. GitOps is basically an approach that is based on keeping a single source of truth. So many times we tend to keep the configuration files, the secrets, and the source codes in different registries. In this approach, we can store all these files in a single Git repository. This will also ease the process of debugging a problem in case something goes wrong. And it will also provide a better collaboration and coordination between the teams. So once the files are added to the Git repository, a CI/CD build is automatically triggered. And once this build is triggered, it will reflect the changes or the real-time changes in the deployments within the Kubernetes cluster. Right, so this is the GitOps approach. Now we'll come to the highlight of the day. What are sealed secrets? Sealed secrets are just the encrypted secrets that are created with the sole purpose of adding the secret configurations in Git. And they are very safe to be uploaded to private or public GitHub repositories just because they are encrypted and not just encoded. And they can only be decrypted by the controller that lies in the Kubernetes cluster. So as you can see, any base64 encoded data can be sealed via the seal secret, and the seal secret can then be pushed to the GitHub repository. And if you apply the seal secret resource in your Kubernetes cluster, the controller will decrypt it via the private key. So,
all right, everyone, just to inform me that I have given her access for the mic. Please try to speak whenever any question is asked.
thank you so much. So I'm sure you must be aware of symmetric and asymmetric encryption. So this uses both these encryption methodologies, right? So this is what seal secret is. Any questions up till now? Okay. It's a very important question. Why to use seal secrets? We cannot store the sensitive information like passwords or secret tokens in a public repository. And especially the secret YAML, we cannot store the secret YAML in GitHub repository because this is just a base 64 encoded value and it's very easy for anybody to decode this value. Right? So they are not encrypted, they are just encoded. And it is very easy to decode it. So the two main reasons would be we can upload the seal secrets in the GitHub repository and not the secrets. And the secrets are very easily decoded if they're accessible. So as you can see, if I try to encode my name, it will give you this value. And if I try to decode it via the same base 64 binary, I'll be in very less amount of time, I'll be able to encode the secret, right? So it's advisable to encrypt the secret as well. Components of seal secrets. Seal secret has three components. One is the controller that is deployed to the cluster. Second is the CLI tool that is called kubeseal. And the third is the CRD. CRD is the custom resource definition for seal secret. So the job of controller is actually to manage the seal secret deployment in the Kubernetes cluster. It has a set of public and private keys that we are going to discuss in the next slide. And these keys are used for encryption and decryption of a secret value. Then we have a CLI tool called kubeseal. This will create the CRD for us. It will also take the public key from the controller and it will actually encrypt the data for you. Right? This is just the CRD. This is the custom resource definition for the seal secret. And we can apply this seal secret in the Kubernetes cluster. We can also store the seal secret CRD in your GitHub repository. So these were the components. How to use seal secrets? It's very easy and very interesting as well. Please follow this particular slide very importantly because this is what we are going to see in the demo as well. If you have any questions, I'll repeat this again. But feel free to, yeah. Any questions?
Yeah, one question. So we can't use, you are saying we have to, we can't hardcode this credentials in the GitHub, but we are having an option of secrets in GitHub.
Yeah, we do have an option of that, but in case, let's say you are working in a team, right? And everyone has the access to the same repository. If you can decrypt that secret, anybody else who has access to your GitHub repository can also easily decrypt the secret. Okay, I mean, okay. if you're working in a team, imagine that if you're working in a team and you have a certain credential that you do not want to expose straight away to the team. You should only have the access if let's say you have multiple environments and you are providing you have a single registry, and if you want to have multiple teams working on that particular repository, your GitHub repository, that you wouldn't want your QA or a developer to have the prod credentials, right? But they will have access to the secret.
Yeah, I got it. I just got confused with the your GitHub actions. Actually, that secrets are only for the GitHub actions only. Workflows.
Okay.
Sorry.
All right. Not a problem. So how to use seal secrets? The seal secret controller, it generates a 4096-bit RSA key pair, which has two keys, obviously private key and a public key. The private key is stored in the form of secret in the same namespace as that of a controller. And the public key, it is made public to encrypt the secret. This is the kubeseal client that I was talking about. So this uses this public key to seal the sensitive data, and how it does is it creates a random session key. A random session key is the one that symmetrically encrypts the data or your secret value, and then the session key is also asymmetrically encrypted with the controller's public key. Right? And once this is done, the kubectl will create a CRD for you. This CRD would be of seal secret. You can easily push this to your GitHub repository. Once you apply it to your Kubernetes cluster, the seal secret controller will use this particular private key to decrypt this secret. And once it decrypts your seal secret, it will create a resource of secret for you, and this resource will be consumed by your pods. Is this clear, or should I repeat? Let me repeat for everybody.
Yeah, can you repeat from the CRD seal secret?
I'll repeat from the beginning. So this is the seal secret controller. I'm sorry. So this is the seal secret controller. This will create a RSA key pair for you. This key pair will consist of private key and public key. Private key will be stored in the form of secret in the same namespace of the seal secret controller. And the public key will be made public to your kubectl client. This kubectl client will have two methodologies for encryption, one symmetric and one asymmetric. A random session key will be generated that will be symmetrically encrypting your data, and this random session key will itself be asymmetrically encrypted by this public key. Right? Once this is done, it will create a CRD for you, which is seal secret. This seal secret, you can push this YAML straight away to GitHub. Once this is pushed to GitHub, anytime you want to deploy it in your Kubernetes cluster, you can. And once you deploy it, the seal secret controller will use this private key to decrypt the value of this seal secret. Once it decrypts it, it will create a secret resource out of it. And once the secret is created, the bot will use it.
Okay.
Is it clear to everyone?
So this CRD is pushed later on pushed to the my repository only.
Yeah.
Okay.
So this is not automatically push. You can always have automation in build, but this just creates a CRD for you.
Okay.
You can push it on your own.
Okay.
Any other questions?
So, can you hear me?
Yeah.
So, is there any change we have to make in secret object?
No.
No? Okay.
Any other question? We'll understand it better in demo, but still, if you have any questions in the concept or how it works.
No issues.
All right. If you're good, then we can move to demo. Is this visible for you? I don't know how to enlarge the screen. I was looking for options, but is this visible to you?
Yeah.
Okay, so this is just a control plane. This is a code cloud playground that I've used, and it has the Kubernetes playground version 1.24, right? So what I'm going to do, I am going to execute a couple of steps. I have already added these steps here. I am also in the way of writing. I have the final draft ready. I'll be publishing a blog that has all these commands, so you can try it on your system as well, right? The first thing that we're going to do is
upward arrow, Vidushi, you can use that. Check if that, then you'll be able to share in full screen on your
upward
right side. Yes, below.
This
Yes,
one.
yes.
This will open in a new window, but okay. Yeah, this is better. Thank you. The first thing that we are going to do is we are going to install the kubectl binary. So this binary will get installed in a form of tar. We will untar this binary, and this is the client that is present here. Now I'm going to install this client, and I'm going to add it to my user local bin. So this is just how I would install the kubectl client on my system. Right, once this is done, I will add the deployment of the controller. I have straight away applied the YAML that is present in the official GitHub repository for seal secrets. So this will install the controller deployment for me. And if I go to my kube system namespace and I grep for controller, I'll be getting the deployment. So this is a pod of controller which is running. Also, if you want to make changes to this deployment, we also have Helm charts in the picture. So if you want to change the namespace to which your controller gets deployed, you can do all those changes there. Let me show you the logs of this pod. As I mentioned earlier, the seal secret will create the public key and a private key pair for you, and this private key will be written to this particular secret. So the name of the secret is seal secrets -key SW6ZR. So this is the secret that will get created in the same namespace, which is kube system, and this is the public key part of it. So in the logs also, the seal secret will publish the public key. Right, once this is done, let me also show you the content of seal secret. So this is, sorry, not seal secret, this is the private key that it creates. So this is the TLS cert and the TLS key that it creates. So this is the private section of it. Once this is done, now I'm going to use the secret.yaml source. So this is just a basic manifest for secret. It has the kind as secret. It has also the name as seal secrets and the namespace to which it will get deployed to, and just one data, which is the database password. So as you can see, this is just an encoded value, and I'm going to save this. And now I'm going to ask kubectl to use the controller that is deployed in the kube system namespace, and this is the name of the controller, and give me a format of YAML and copy the content to a file called sealsecret.yaml. So if I open this file, it will create this CRD that I was talking about. So this is a CRD for seal secret. It will have the DB password encrypted. So as you can see, the value that was there on the secret.yaml was encoded, and this was very easy to decode. But this is encrypted, and this will only be decrypted by the controller's private key. So once this is created, I'm going to push this file in my GitHub repository, and that GitHub repository, this file would be very safe. And whenever I want to publish this on my EKS cluster or any other Kubernetes cluster, I'll just apply this file. So let me show you what happens if I apply the seal secret. It will complain that the test namespace is not there. So I will create a namespace called test and apply this again. So it says the seal secret has been created. I will get the seal secret. So this seal secret got created. I will also check whether it created that secret for me. And yes, it did. So you remember how a pod in a deployment works. If you delete the deployment, the pod will automatically get deleted because that is the one which is governing the pod, right? So it happens similarly in the case of seal secret as well. If I delete this seal secret, it will also delete the secret. So it says no resources found in test namespace, right? So it acts as a wrapper around the secret that it creates. So it's very important for us to have the seal secret in place for the corresponding secret, right? So any questions up till now or any doubts?
Yes,
So-
so one question here. Like we have to use kubectl first to encrypt it, then we have to push it to repo, correct?
Yeah.
Okay, so first, so how we are going to manage, like what is the password we put? How we are going to manage that? We have to manually put it somewhere?
Yeah, so this is the short secret file that you would need to create. And this secret would not be pushed to your GitHub repository. This is just the basic secret.yaml manifest. You'll have your password here.
Yeah.
And this is yeah.
But
This will be in your controller box.
Yeah, but let's say we updated our repo with the encrypted one. So how we are going to remember like what password we encrypted? Do we have to put it somewhere in our inventory so that we can have a control on the password. Let's say something went wrong and we
No,
came to
that is correct. Yeah, that is correct. You'll have, obviously you'll have to store your password somewhere, right? You cannot have just a single GitHub repository that will have your password. But this is just for the case when you want to have the secret YAML configuration file stored in your GitHub. Let's suppose you're working only with GitHub, right? For your use case, what you would do is if you go back to your Kubernetes cluster and if you grep for that secret that it created, your seal secret created, that would also be one way of finding the original password.
yeah. So
Let me show you
that,
how. If you apply your seal secret, yeah, go on.
means from cluster itself we can decode it using the resource, correct?
Correct, because it is creating that secret file for you, right? See, it created this for you. So if I get this secret and print it here, this will give me this DB password. And I'll just decode it.
Okay, got it. So basically in backend, it's creating the secret with the same approach how we generally create. But
yeah,
but
just to upload it to your GitHub repository, you'll have the seal secret. You do not need to explicitly create secret. Once the CRD is created, you'll just apply it and that CRD will itself create a secret for you.
But how it solves the problem? Like it is still available on the server.
Can you come again?
Means how does it solve the actual problem? Like it is still available on the server level. If we are going to decode it using the base 64 again, then we are going to get it, correct? So earlier
correct.
also.
So yeah, the use case is different. So my use case is it is following the GitOps approach. I'm not saying you would not be able to decode it. If you have the access to your cluster, then definitely you'll be able to decode your secret. So that is why the first of those slides I mentioned that you need to follow the best practice to protect your secret. So that works hand in hand with it. That is not an alternative to seal secret. Seal secret is just a way wherein you can follow the GitOps approach.
Fine.
Now this way you would have the secret stored in your GitHub repository, but that secret will not have the encoded data. If you have access to the cluster, then definitely you can access the secret. And that was what this slide was about.
Yeah, got it.
Suggestions.
Something we have, we can have some API which can scramble the password and then unscramble the password and create the secret. Something like that we can use. We have in our
yeah, definitely. We can merge many solutions into it. This is just following a practical way to GitOps. It's just that. We can definitely integrate it with some other tool. We can also have it integrated with 1Password. So that way we do not have to create the secret from scratch. That will be integrated with any CI tool and that will be straight away taking that password from your single source repository and then it will follow the CI and then pushing that secret to your GitHub. So this could be done in many ways. This is just a tool for GitOps. Okay, one main question that I had when I was learning seal secrets was, what if the controller got deleted? The controller that is managing your private key got deleted. And what if your private key secret got deleted? So this will fall under the category of disaster recovery, right? So it is advisable to store the secret that has the private key somewhere safe. So whatever secret management tool you're using or any safe space that you're using, let's say AWS secret manager or 1Password or any other client that you're using to manage your secret should have this YAML. And what you can do is follow very simple steps. You can copy the content of this secret in a master.yaml file and you can keep this master.yaml file safely in any desired location. So if you have the backup of this private key, whenever you install your controller again, this will take in the existing private key. So for example, right now what I'm doing is this has the secret. This is the secret that has the private key. I'm adding this YAML to a file called master.yaml, and now I'll be deleting everything. So the first thing that I'm going to delete is the secret itself. This is deleted, so if I get the secret, I wouldn't get anything. I made a mistake.
Your secret is overwritten. This master.
Yeah, not a problem. But anyways, my point was that if I delete the CID, let me do it very quickly. We have some time left. So that secret would have been created. I'm overriding my master.yaml. Now my master.yaml is safe. Yes. So now I will be deleting the controller file. And I would also be deleting my secret. Yeah. So let me confirm if everything has been deleted. The controller is deleted. And the secret is also deleted. So now I'm going to apply that secret again, which was stored somewhere safely. So if I apply this master.yaml, this will create a secret for me. And if I get the secret now, it created this secret that has a private key. And now I'm going to install the controller again. This one was to delete. So this command will apply the controller's YAML, and now my pod would have been created in the same kube system namespace. So this is the controller pod, and if I check the logs now, if you remember earlier, it had created the set of public keys and private keys, and it printed the public key here. So now it says that it was searching for existing private key, and it found the private key in this secret. So it will use the existing private key, right? And all your seal secret CRDs that you might have created when you were using this particular controller will remain intact. So this is the way where you can manage the disaster recovery part of seal secrets. Any questions in this? Okay, I will take them as a no. So yeah, that was all about seal secrets. If you still have any questions that you might have come across later, then please feel free to reach out to me. This is my Nodlist email ID if you are a part of Nodlist, and you can also connect with me on GChat. Thank you for attending this session. I hope you liked it and got a little knowledge of how seal secrets work. If you want to discuss anything, please feel free to reach out to me. Thank you so much, everyone.
Thank you so much, Vidushi. That was an informative session. So if anyone has any query, kindly let know, Vidushi.